All right, so take a second to read through this problem. I want to pause it first and then read through it. But basically what you have is you have a submarine that as it goes up and down in the water, they will either add water to the tanks and then it'll sink, or they'll push the water out of the tanks, making it lighter, and so the submarine will float. That's kind of how it works. But very important here is this basic idea that the volume of the submarine never changes, right? If you pump a bunch of water out of the tanks, it's not like the submarine shrinks. And if you suck a bunch of water into the tanks, it's not like it gets bigger. So the volume is not what's changing. What's changing is the density, and that's happening because you're either adding mass to it by sucking in water, or you're subtracting mass by pushing out water. And so the thing that it's asking here is to make the submarine float neutrally, and neither float nor sink in the ocean, what volume of water does the submarine need to subtract from its tanks? Now, that's a little bit misleading right there, because it says, what volume of water does the submarine need to subtract from its tanks? Well, we're not really subtracting volume, though. We can answer the question in volume, but we're not subtracting volume. We're subtracting some mass. And so that's what's kind of confusing. So let's talk about this. To make it float neutrally, what has to happen? Well, in order for that to work, the density of the submarine has to equal the density of the water. That's just what needs to happen. And we discussed in our notes, if we use our flux capacitor here, that density is the same thing as mass divided by volume. So what we could say is, you know what, we have a mass to the submarine. They tell me that right here. There's the mass. And we have a volume of the submarine. They tell me that right there. And we even have a density of water that they tell me right there. So if I was to plug all these things in, right? So I have density, remember, the density of something is just mass divided by volume. So the density of the submarine is just the mass divided by the volume. So we could say the mass of the submarine divided by the volume of the submarine. That still needs to equal the density of the water. All right. So we have that basic information, but here's the thing. Remember, we're going to subtract some amount of water from the tanks, and that's not going to change the volume because the volume never really changes. It's really going to change the mass. So we need to rewrite this equation as we have the mass of the submarine, and we are going to subtract some mass of water from the tanks. We're going to divide that by the volume of the submarine, and that should equal the density of the water. Well, this isn't that bad because they gave us all these pieces of information. So let's just plug it in and we'll solve for the mass of the water. So the mass of the submarine starts off as 8 times 10 to the 6 kilograms. And then we could say minus the mass of the water, which we don't know yet, over the volume of the submarine, which is 7.8 times 10 to the third cubic meters. And this needs to equal the density of water, which we know is 10 to the third kilogram per cubic meter. All right, so let's take a look at this. I'm going to move all this stuff over here so we can kind of focus in on this problem. So we are going to solve this algebraically. Not that hard. First thing we're going to do is we see that we're dividing by this 7.8 times 10 to the third, so we're going to multiply both sides by that. When I do that, when I multiply this side, it goes over here. And obviously, if I was to multiply by 7.8 times 10 to the third cubic meters, it cancels out. All right, so then what do I have? I have 8 times 10 to the 6 kilograms minus the mass of the water equals, what happens over here? Well, I would have kilograms over cubic meters times cubic meters. So the first important thing to recognize is that the cubic meters are going to cancel out. And then I have 10 to the third times another 10 to the third. Well, 10 to the third times 10 to the third is 10 to the 6th. So this becomes 7.8 times 10 to the 6, and now we just have kilograms. Okay, we're getting closer. Now we're going to do some some more subtraction. I'm going to subtract 8 times 10 to the 6 kilograms from both sides. That obviously cancels that out. That means that the negative mass of water equals negative 0.2 times 10 to the 6 kilograms. Now we have a negative on both sides. Obviously, we could just multiply both sides by -1, making it positive. All right, so I have the mass of the water that we're going to take out of the tanks. It's going to be this amount. But this is not proper scientific notation. If I wanted to write this in proper scientific notation, I need my significant figure 2 to be in front, and it would be 2.0 times 10 to the 5th. Or if you want to just get rid of scientific notation altogether, you could just say this is 200,000 kilograms. All right, awesome. I got the mass of the water. Good. Am I done? Well, no, not really, and here's why. If you remember, let me move all this out of the way now. The question was really asking for the volume of water that we're going to subtract. We had to find the mass first because we couldn't really just go in right into the volume. But we could find the mass. So now that I have the mass, let's think about how I could convert that to an answer. Because remember, again, I want the volume. Well, volume is simply mass divided by density. Well, I have the mass of water, and I have the density of water. So I could find the volume pretty easily. The volume of water, which is what I'm looking for, is going to equal the mass of water over the density of water. Well, I have all these numbers. So the mass of water we already know is 200,000 kilograms. And the density of water we already know is 10 to the third. 10 to the third, by the way, is simply 1,000. And this is kilograms per cubic meter. So the numbers, it's kind of easy. 200,000 divided by 1,000, that's pretty simple. It's just 200. But what happens over here with these units? Let's think about that. Well, when you're dividing by a fraction, isn't the same as multiplying by the reciprocal? So I could kind of think of this as multiplying by cubic meters over kilograms. And then you can see the kilograms would cancel out. So it turns out that this volume of water is simply 200 cubic meters. And that is the answer that they're looking for. And if they were to write this in scientific notation, it would be 2.0 times 10 squared cubic meters. So we could use that one as well. Lots of stuff there. Fun problem. See you guys in the next video.